What are you doing here? Welcome back to the fourth lesson on the Foundations of Algebra course. Let's get right to work. We've seen that algebra is the study of the operations on the real numbers, and we got a good handle on what the real numbers are. They're the integers and all the numbers in between. So we spent our time looking in between. In our first group, we looked at fractions, right? But now, today, we're going to see the true nature of the real numbers. Here it comes. Guys, decimals, they're the key. Turns out, decimals are just fractions in the tens family. So what I mean by that are fractions like tenths, hundredths, thousandths, etc. For example, 7 tenths, 31 hundredths, 9 thousandths, 4,301 ten thousandths, those are all decimals. In fact, there they are, 0.7, 0.31, all the way down the line, okay? And by the way, so 0.7 or 7 tenths, if you wanted to represent that, then we've got it covered, right? Because 7 tenths is just a fraction. That decimal, 0.7 or 7 tenths, we could represent it with bars just like we always would. There it is, 10 equal pieces and color in 7. Nothing to it, all right? I'll tell you what, if you wanted to go crazy with a decimal, and that's a good idea. Let's go crazy because that might let us explore all the different decimal place values. That turns out to be super duper important. So here's a huge decimal. What am I saying? It's a long decimal. Actually, as a number, it's very, very small. So let's take a look at these place values. I'm going to go, just to the left of the decimal point. That's our ones. We don't have any. So this is a small, tiny number, okay? The 4, right to the right of the decimal point, that's in the tenths. One place over, that's the hundredths. The 5 is in the hundredths with a th on the end. See those fraction denominators with the tens? Tenths, hundredths. Now, new thing, thousandths. The 8 is in the 10 thousandths, 100 thousandths, millionths. I want to draw your attention to something. See, thousandths, then we had 10 thousandths, 100 thousandths, and then a new name, millionths. Now watch. The 1 is in the 10 millions, 2 in the 100 millions. So again, we get that common thing, 10 of them, 100 of them, new thing. Okay? We've seen that before. Billions, 10 billionths, 100 billionths, trillions. So this number is actually a fraction with a denominator of 1 trillion. So it's in the trillions. Pretty crazy, huh? Take a look at that structure. It's pretty important that you recognize all those places and that you can accurately name them and count with them. Just like in the whole numbers, every time you move to the right, it's 10 times as big. Every time you move to the right, it's 1/10 the size. It's 10 times smaller. Okay, and that holds as we go to the right of the decimal point as well. Okay. Now, I'll tell you what. Let's remember how we go between these things. If you have if you have a decimal and you want to write it as a fraction, well, you guys probably remember it's all about figuring out where that last number, in this case the 7, what decimal place is that in? Well, going back to our list, we can just remember that going through our tenths, hundredths, thousandths, 10,000, 100,000, millionths, 10 millions. It's in the 10 millions place. That's our denominator. See the 4 to the left of the decimal point? That's our whole number. So this is definitely going to be a mixed number. This decimal is more than 1. So we're going to have 4 and some amount of 10 millions. And the sum amount is just that decimal, the digits you see to the right of the decimal point, right here. Okay? Notice 810,427 10 millionths. That's the fractional part. Okay? All right. Percents are always super cool, right? We know they're just a different way of saying hundredths. So now that translates very easily into decimals. So if we have 7%, which we know is 7 hundredths, now we have a nice decimal way of writing that as well. 7 in the hundredths place. Looking good? All right. Let's run through a few basic ideas just to make sure everything's making sense with these decimals. The first thing is, in terms of writing them, you should know that adding zeros onto the end of a decimal number doesn't change the value. So like, for example, 0.7, that's the same as 0.700. Those zeros on the end do not change the value of that number. And likewise, 0.0415 or 415 10,000ths, it doesn't matter if you tack on those 4 zeros onto the end. It's the same exact number, okay? One little bit of warning though. Zeros in amongst the digits, the non-zero digits, like this one right at the front, that does matter. That zero does matter, all right? It's the ones at the end. You can just tack them on to the end and it doesn't change the value. Okay, another basic idea is close to. We've worked on that in all our number sets so far. So you should know that 7.0639 or 7.9002, you want to get a handle on what those are close to, just a nice number sense. Well, 7.0639, that's really just close to 7. And 7.9002, that's really close to 8. Well, why? Why is that? They're sort of the same length. Guys, length has nothing to do with the size of a decimal. So take a look. The magic number is the tenths digit, all right? The 0 in that top number in the tenths place, that's what's making this whole decimal very, very close to 7. And likewise, the 7.9 whatever, that's really, really close to 8. Okay, so it's the tenths rule in terms of seeing what whole number those decimals are close to. All right. Half. We've seen half as a really important benchmark, a nice reference point, and with decimals, that's no different. You just need to know that 0.5, in other words, 5/10, that's 1/2. So now you've got your reference in the decimal world too. So 4.512, well, that's greater than 4.5. And 4.71, that's also greater than 4.5. 4.5 is 4.5. And 4.39989, well, look at that tenths place. Still, it rules there. That's less than 4.5. Okay, less than 4.5. All right, comparing to half stays important no matter what form of these numbers we're looking at. Now, talk about rounding in general for a second, because sometimes decimals get so long we don't need all the information. We've sort of seen that in that close to kind of examination. Well, if you're asked to take a number like 6.837 and round it to the nearest tenth, you guys probably remember how to do this. I just want to run through the idea just to make sure we're on the same page. To the nearest tenth. So what number's in the 10th place? The 8, right? The 8 digit is in the 10th place. So to round to the 10th place, you actually look to the place to the right. So the hundredths place in this case. So look at that 3. Any digit 0 up to and including 4, we will keep that digit the same. Keep the 10th digit the same. 5 or higher in the next place, then we round our digit up, okay? So the 8 is our digit in the 10th place, so we look to the right of it, we see that 3, so that means keep that 10th the same. Drop everything else after it, and we just see that that's about 6.8, rounded to the nearest 10th. To the nearest hundredth, we do exactly the same thing, except now it's the 3 digit that we're really interested in. We look to the digit directly to its right. It's now a 7. So remember, 5 or higher, 5, 6, 7, 8, 9, in that place, we round our digit up. So that means that to the nearest hundredth, this is 6.84 rounded up. Okay? Excellent. Just comparing in general, you should know, again, length has nothing to do with who's bigger in the decimal world. What you want to do is just line up the two numbers. Let's say you're trying to decide between these two, who's bigger. Well, just line them up on the left, and just start checking decimal place by decimal place. Start on the far left. So they're the same in the ones digit, we got 4s. Same in the tenths, there's 7. But look at that, in the hundredth place, there's a difference. And as soon as you see a difference, game over. Whichever one is the bigger digit, well, that whole decimal is the bigger number. So since 9 is bigger than 8, then that bottom number is the bigger one. The top number is in fact smaller than 4.7903. Looking okay? Line them up, just examine them decimal place by decimal place. Now, here's the huge fact. This is super duper important. And it's actually sort of letting on this nature of the real numbers. Every real number is a decimal. And it might be in disguise. It might not look like a decimal, but it is a decimal. Okay? Box that in your notes. Every real number is a decimal, maybe in disguise. So for example, the number 3. This is what I mean by maybe in disguise. It doesn't look like a decimal, but you guys know, of course, we can write it as 3.0. 3/4. Well, you know what? Remember that was 75%. We talked about those famous percentages. 75 hundredths or 0.75. So even 3/4, it's really 0.75, 75 hundredths. 3/8. Now, that one might not be as easy to convert into hundredths or tenths or thousandths. I'm not saying you can't, but it might not be as obvious as the 3/4. Let me just tell you, instead of trying to figure it out, can we anti-simplify it into a tenth or a hundredth or a thousandth or whatever? Just go ahead. You can always just divide it. So 3/8, if I do that division, if I take 3 and I divide it by 8, be careful with that order, right? 3/8, 3 divided by 8. Well, 8 doesn't go into 3, so let me drop that decimal point. Hey, we're using that top fact. 3 is really the same as 3.0, and let me put the decimal up there. So 8 goes into 30. Yes, it does. 3 times 24. We can subtract it. We get 6. Let me drop another 0, right? We can tack on zeros on the end all day if we want. Bring that down. 8 goes into 60. Yep. 7 times. Subtract that. Okay, not done dividing, so let me keep going. And 8 goes into 40 5 times. Ooh, and look at that. I get 0. I'm done. So 3/8 is really 0.375 as a decimal. Looking okay? All right, one more. This one really surprised a lot of people. This is pretty wild. 1/3. Now, no matter what we do, whatever form of 1 we multiply in, we're not going to convert this into a tenth or a hundredth or a thousand, one of those fractions in the tens family. But we can do our division, right? So let's do it. 1/3, or 1 divided by 3. Let me drop this down, add a 0. 3 goes into 10 3 times. Subtract 10 minus 9, get 1. Okay, put a 0 here. 3 goes into 10 times. Well, actually, we just did that, didn't we? It goes 3 times. 3 times 3 is 9. Wait a minute, another 10? Wait, this is just going to continue, isn't it? And I'm just going to get more 3s up in the answer. So this decimal is actually infinite. There's no end to it. It's just 0.3333333 all the way down. Wow. Okay. Well, let me get that out of your way. Excuse me. look at that then. 0.3333 dot dot dot. The dot 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 just means keep on doing what you see, and that's pretty easy. It's all threes. There's also that notation where you can put the bar over the digit or digits that repeat. Okay, you guys have seen that before. That's pretty wild. All right, but even that weird thing, it's still a decimal. Might be an infinite one. All right. Now, all of those numbers, in fact, all the numbers that we've been looking at up till this point, they're all rational numbers. Okay? All those decimals that we've looked at so far are rational numbers. And you might think, well, wait, don't we have them all? I mean, is that it? So the rational numbers are just the real numbers? It turns out, and it's so bizarre, we're missing some. There's this other set of decimals, and man, are they crazy. We got our rational numbers. The other set is called the irrational, the not rationals. So they're the other decimals, and they are as weird as they come. Now you might think, well, okay, there's just like a handful of weirdos in the group. No. There are more irrational numbers than there are rational, believe it or not. So it's such an insane idea to think about, right? There's these weird numbers, and you start to poke around. It's like, oh my gosh, there's more here, more here, more. There's just way more irrational numbers than there are rationals. Well, just as an example to show you what these numbers are like, let's take the square root of 10. Now the square roots, and I know you guys have worked with before, like square root of 9 is 3. Square root of 16 is 4. You guys remember why? Square root of 16 is 4 because 4 times 4 gets you 16. Okay? So square root of 10 is you're probably thinking, well, square root of 9 is 3. Square root of 10 is probably a little bit more than 3. And you're exactly right. But here's where it gets weird. The decimal version of square root of 10, look at that, 3.162277666016837 dot dot dot. But that dot dot dot's a little different than the dot 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 we had before, where it was like, oh, you mean just keep putting threes forever? Like 3, 3, 3, 3, 3, 3, 3. This one, we don't know what's coming next. That's why I put the little question mark there. In fact, this decimal goes on forever. Now, we've seen that before. That's not a big deal. But it does not repeat a digit or digits. Every time you see a decimal place value, the face value in that decimal place, it's something that you could never predict. You never know what you're going to get until you see it. They're just bizarre. All right? Well, with them. Oh, wait a minute, I do need to tell you this. Even though they're so weird, like they go on forever and you never know what's coming, there's still an exact spot on the number line, right around 3. You can see it in the number, just a little bit to the right of 3. That's where square root of 10, this number, that's where it lives. All right, with that, I think we're ready to see the real numbers in all their glory, okay? The integers, and then all the numbers in between. And now I hope you have a better appreciation for how many numbers are in between and the weirdness of some of them, right? The rationals, the irrationals, the fractions, the rationals. Look at this. There they are. Man, and by the way, it looks kind of crowded in there, but that's just a sampling, okay? A paltry sampling of real numbers in between those integers. But that's it, okay? The real numbers are all the possible decimals, and you're looking at a nice representation of them there on the number line. Whew, okay. This has been a mad rush to review those real numbers, but I hope it was worth it. I hope we filled in some things that might have been giving you trouble in the past, or giving you a chance to just go back over and make sure this stuff is super solid, because we got to have the real numbers. They got to be down pat. By the way, the real numbers, if you're tired of writing that over and over again, there's the symbol for it. It's just this kind of double-edged R for reals, all right? So we're good with them. We now can check them off. What's coming up next is the operations, and that's what we'll turn our attention to in our next lesson. Good work today, guys. I'll see you then.